Hello Pirates, this video is just to go over the cell theory timeline with you. I know a couple people had questions about the microscopes because the video didn't do a very good job at talking about microscopes, if really talking about them at all. So that is what this video is about, just going over the microscopes and the cell theory timeline. So when you are looking at the history of cell theory is the theory of cells, that all living things are made of cells. And if you look at your essential question, part of this topic is to help you guys understand how in any field of scientific discovery that numerous scientists lead to the development of new theories and new ideas. So it's very rarely just one person with one idea. Cell theory is an excellent example of how the ideas of many people over a few hundred years really brought us to the knowledge that we have about cells today. So in order for us to understand and see cells at all, we first needed to have the invention of the microscope. So Hans and Zacharias Janssen, in 1590, they were optical lens makers. They created the first compound microscope. And like you guys saw in the video from TED Ed, this was a huge invention. You know, people were so excited to see what the world looked like in a way that we couldn't see it with our own eyes. So before this, we didn't know what, our fingernails maybe look like or the details on a leaf. But with the new microscope, people could see things that they never knew maybe existed, or details that they didn't know were present. Fast forward, about 70 years, Robert Hooke is using one of these microscopes that he has also worked on. And Robert Hooke discovers cells, and he names them cells based on the tiny rooms in a monastery. And the cells that he was looking at specifically is Robert Hooke was able to make really thin slices of cork, which comes from a tree. And when he looked at the cork, he could see all these tiny little spaces, these tiny little rooms. And so this is why he named them cells. So, he took from the cork tree. All right, Anton von Leeuwenhoek was another scientist who was fascinated by the microscope, and what he discovered is that bacteria, and he was looking at his dental scrapings, and with his dental scrapings, he noticed little tiny creatures in his dental scrapings, and he called them animalcules. And this is huge because, again, people don't know about bacteria. Now they know that there's microscopic living things out there. Before, they would have thought that just like ants or other tiny little insects were the smallest living thing. And now finding out that there are, things like bacteria. And you guys can think of how eventually this leads to us understanding that, when we're sick, we have bacterial or viral or fungal infections that typically those illnesses are not coming from, a curse or people being hexed or anything like that. So von Leeuwenhoek discovers bacteria. Matthias Schleiden is a botanist, and, well over 100 years later, like 150 or so years later, this is a botanist who is looking at plants under the microscopes, and he noticed that every single plant he looks at is made of cells. And another scientist who studies only animals, he noticed that all animals are made of cells. So Theodor Schwann, and Schwann rhymes with swan, and a swan is an animal. So that's how I keep that one straight. Schwann, swan, animals. All right, so these two, their work that animals are made of cells and plants are made of cells, this leads to the part of cell theory, because everything for a while was categorized as either being a plant or animal, even though that's not how we do it today. But this led to this determination that all living things are made of cells. And since we've been looking at living things under the microscope all the way back in 1674, every living thing we found is made of cells. And so that makes it part of this cell theory. All right, Rudolf Virchow, he is a scientist, and he is interested in where cells come from. So do cells just crystallize and poof into space like spontaneous generation? or do they come from other cells? And so he proposes the idea that all cells come from other cells, and today we can see this on a microscope, that cells divide to make more cells, that cells are not just poofing into existence. And this brings us to another part of the cell theory, which is that cells come from pre-existing cells, which means for you, your cells, you didn't just poof into existence one day. You came from cells from your biological parents, and your biological parents came from cells from their biological parents. And we could trace your family line, all the way back to the first cells, because all these cells have derived from those cells, which is kind of cool to think about. It's cool to think that, we could trace your heritage. Someone in your family was around in 1590 or 1400 or 1200 or back 100,000 years ago. Like, you had relatives that lived then. Your family just might not have record of who they were. All right. The next one is this improvement to microscopes. So in 1886, there is the invention of the first light microscope. And the first light microscope is huge because for the first time we can see things that are currently living. We're not just looking at dead cells and tissues. And this is the kind we use here at school. So we use a light microscope, and it shines a light through the specimen so that we can observe what we are seeing. The other type of microscopes that are out there are electron microscopes. Now, electron microscopes work differently because they kind of like beam electrons at the specimen, and the electrons bounce off and it creates an image from that. So in the electron microscope, the organism has to be non-living. So we're looking at non-living cells, but it's going to give us really good magnification. Images seen under the electron microscope, sometimes we can look at images up to 1 million times what we can see with our eyes. And that is a really improvement for what we can see with the light microscope. With the light microscope, you're looking at 1,000 or maybe like 2,000 magnification tops. And there's a big difference between 1,000 and 1 million. So the type on the left, that is the transmission electron microscope. And this does almost like cross-section images. So we get 2-dimensional images with the transition electron microscope. And with the scanning electron microscope, it scans the surface. And when it scans the surface, we get a 3D image. So there is a transmission electron microscope and a scanning microscope. And you guys can imagine, since the 1950s, this has greatly changed what we know about cells, because we can see organelles, we can see the structure of the organelles, and this is stuff we just wouldn't have been able to see with the light microscope. All right, wrapping it up, the cell theory. And when you guys take a test on cell theory, there are 3 components of cell theory, and multiple choice tests oftentimes have 4 choices. So usually a test question is worded as, which of the following is not part of the cell theory? So it'll give you the 3 parts, and one of the choices would not be part of cell theory. That is a good hint for you guys as you get into standardized tests. So the first part was that all living things are made of cells. And the second part is that cells are the basic functioning unit of life. So the most basic living thing is a cell. So this is the most basic functioning unit of life. That's a T. All right, and the last part of cell theory comes from Virchow, and that is that cells come from pre-existing cells. And we will talk more about that with evolution, because sometimes students do ask, they do say, if they come from pre-existing cells, where did the first cells come from? So we'll look at theories on the origin of cells later on this year. All right, the last piece here is for you guys to understand the difference between a scientific theory and a law. Something to remember is that these terms are not used casually in science, and both of these are based on evidence. So they're both based on a lot of evidence. The scientific theory, and you guys can just kind of think of some scientific theories you might be familiar with, like maybe the Big Bang theory, now the cell theory, the theory of evolution. Climate change is a scientific theory. Atomic theory, that matter is made of atoms, that is a scientific theory as well. And then, when you think of scientific laws, these are usually going to be things like maybe Newton's laws of motion, or maybe you're thinking like the law of gravity. So what's the difference? If a scientific theory is classified as a theory and not as a law, it doesn't mean that it's not valid and there isn't evidence and proof to support it. It just means that it's unifying a broad range of content and information. For example, with cells, there's information on how cells work, how they divide, how plant cells work, how bacteria work. And so a theory is going to have a broad range of data. So a broad range of data and info, and the theory unifies it all under one idea. And this is stuff that we're still researching. And it doesn't mean that it's not true because we're still researching it. So it's not that you're not made of cells because we're still researching it. We know you're made of cells. It just means that we are still researching cells and still learning about them because they're so complex and our technology keeps improving, so we get better knowledge about that. So this is stuff that's still being researched. It's still being edited, what we know. These theories, they explain why something's happening. So for example, like the theory of evolution, we know that life changes over time. We see the fossil record. We can see that horses today are different than horses of hundreds or thousands of years ago. The theory of evolution seeks to explain why they changed. So in addition to like selective breeding, what changes in their habitat may have happened, why did certain traits selected for? This is going to explain the why. So for example, again, with climate change, we know that the climate is changing. Climate change as a theory explains the phenomena. Why is the climate changing? Okay. And people argue about what is contributing to that factor, but 99% of scientists who are experts in the field agree that humans are contributing to that. When we look at, and we'll look at climate change later this year and all the data and evidence that supports and backs it. All right. Laws then, they are going to explain, they typically are going to explain to us, they typically explain how something happens or what is going to happen. And they're typically not going to be a broad range of data. They're usually pretty straightforward, like force equals mass times acceleration. These things usually have math equations. Like we can do the equation for gravity to determine how fast something falls to the earth. So scientific laws are a little bit more straightforward. They're a little simpler. It doesn't mean we're not exploring gravity anymore. We are, but we pretty much have it pinned down, to how it happens and what will happen when I drop the pen. All right, so what you guys want to do with this one is answer the questions. Answer the questions down the side and across the bottom. That is what you should turn in and submit for the cell theory.